Hi, my name's Scott Dwyer. I'm at the Intel Future Showcase talking about Intel RealSense technology. So, Intel RealSense is an effort by Intel to make the way we interact with computers more natural and more human. So what we've done is we've actually given computers more human-like senses. We've given them smarter ears so that you can interact with your computers via speech, but the other really interesting thing we've done is we've given them smarter eyes, which means we've given computers a 3D camera which can understand depth and distance the same way that we can. And this enables computers to understand us and interact with us in 4 fundamental new ways. One is that computers can now understand our hands. We use our hands all the time. We use them when we talk, and we use them to interact with objects. And so at Intel we thought it would be great if our computers could understand our hands so that we can interact with applications in a similarly natural way. The second way we're making our computers better at understanding us is we want them to be able to understand our face too, because our expressions and what we're looking at are fundamentally important to how we communicate. So with this 3D camera now, the computer can understand 78 points on our face, and applications can use that data to do emotion recognition, so they know how we feel as we use them, and they can adapt to us based on how we feel. The third way our computers can understand us is through natural language, which is really exciting because it's the most common way we communicate, is by talking. So we want computers to be able to understand us naturally, so that if we don't want to use our hands at all, we can just speak to our computers as we speak to each other. And the last way that's really exciting is we want the computers to be able to understand the environment around us, including objects. So with the 3D camera, because we're able to measure distance and depth, we can actually measure the distance and depth on an object, and as we show the computer different perspectives of the object, the computer can actually build a 3D model of that object. We can quickly edit that 3D model, and then we can actually print it. So we can take the real world and make it virtual, and then we can take that virtual world and make it real again, which is really exciting. It's exciting for the maker community. It's going to be exciting for consumers who know about 3D printers but maybe don't have any models to print yet. And the best part about all this technology is that while Intel has a lot of really good ideas about what to do with it, we've developed a set of tools that creative people, artists and makers and software developers can go off and use to bring this natural user interface to their own applications. We want to enable the larger community working on software to deliver these natural, intuitive, and immersive experiences that Intel's working on with RealSense to their own customers, to make computing more fun for everybody involved. So first we're going to talk about 3D scanning. We think 3D printers are great, but the average person doesn't necessarily know how to build a 3D model. And even if you do know how to build a 3D model, it can take hours or even days to do. So we want to make it easier to take objects that already exist and turn them into 3D models. So what we've done with this Intel Bunny Man is we held him in front of a computer that had an Intel 3D camera built in, a RealSense 3D camera. We spun the model around a couple of times, and then we were actually able to turn this physical object into a virtual object. Once we did that, we did a quick edit on it. You can see this is a fully 3D model, but we added a little base so that the model could stand on its own. And then we 3D printed it. So we were actually able to duplicate an object that already existed and print another copy of it, which is incredibly cool. Besides doing simple edits like this, there are other interesting edits you can do to the 3D models. Like we printed another bunny man out of steel, but we actually added a little ring on top to make it a keychain. Besides scanning actual objects, we can actually scan faces as well. So what we've done with this print is we scanned another Intel employee's face, and then we printed out a copy of him. So instead of sending your friends and family photographs, you could potentially send them 3D models. And if you don't have a printer, the 3D scanning is actually still very exciting. If you have an object that's cool to you and you want to share it with your friends, instead of sending them a regular 2D image, now you can send them a scanned model, and they can rotate the model and check it out in detail for themselves. So we think there's a really cool social opportunity with the scanning technology. So we mentioned being able to understand people's face. this is actually how it works. This is our face tracking example, and we're tracking 78 points on the face right now. And you can see we can detect that I'm surprised, or that I'm happy, or that I'm upset. And I can look around the screen, and we maintain the tracking. And this is really important contextual data that applications can use to respond to users. Basically, we want the PC to understand users as humans, and being able to track this many points on the face is an excellent way to provide that information. We mentioned RealSense's ability to track our hands because it's a normal way that we use to interact with the world around us. Here's actually how it works. The 3D camera senses my hand in 3D space, and we are tracking 22 points on the hand, all the joints in the hand. This enables us to produce an incredibly accurate model of the hand that applications can then use to allow a user to use their hands to interact with whatever's going on in the scene of the application. You want to show an example? Yeah?
Sure.
Okay. We'll show this and then just one more thing. Okay. So this game is called Hoplites. It's a little bit like Lemmings. There's little characters over here, and we're trying to get them over here. And the primary object that we use to interact with them is our hand. And so the reason we like this is people don't need to be told how to use their hands to interact with objects. So it's quite obvious. You just walk up to it and you know how to play it.